Welcome. Today, we're going to be talking about building data science applications with TabPy, Python, and R. Before we jump in, by way of an introduction, my name is Nathan Mannheimer, and I'm the product manager at Tableau for the advanced analytics team. So a little bit of background about me. Like I said, I'm the PM for advanced analytics. My team handles some of the statistical features in our product, so everything from as simple as box plots all the way up to k-means clustering, time series forecasting, regression, trend lines. And we also own the code integrations into Tableau for analysis. So you may have seen some other great presentations this week on some of the other dev platform and API work that's being done. What we work on is how to tie in scripts with R and Python and MATLAB into the analysis flow in Tableau. In addition to being the PM, I also teach at the University of Washington. We're based up in Seattle, so I teach in the data science and human-centered design and engineering master's programs, largely on information visualization and how we can tie in the visualization concepts that we've built into Tableau into tools for making more advanced analysis, machine learning and data science accessible to a wider audience. You may not know it to look at me now, but I was also an NCAA swimmer in college, and before working at Tableau, I taught high school in Japan, and as you can see, I'm an aspiring starship captain as well. So, a little bit cheesy, but I always like to start off with a quote, because I think it's helpful to kind of frame the way that we're thinking and the work that we're doing. And so, I love this quote: "Hiding within mounds of data is knowledge that could change the life of a patient or change the world." And that really is what we're all doing here. We are working, analyzing, exploring data, looking for that next insight that's going to help us make a better decision, make a smarter choice. And more, as our technology and our techniques become more powerful, those answers that we come to, those decisions that we support, can change the world. So, to bring it back down from the entire world into this room, although it's a pretty big room, we're talking about our session goals here today. What are we actually going to talk about? So first, quick show of hands. Who here is familiar with Tableau's external services for R and Python or has used them? Excellent. All right, so we're not going to spend too much time on the basics. I know there are plenty of other sessions that cover that. I'm going to quickly run through how they work in maybe just a few minutes, and then we'll move past that to the good stuff. So we're going to explore some real data science use cases that we've come across as the advanced analytics team working with customers in Tableau. We're going to learn how those users and those customers adapted code to use inside of Tableau and really expand and share the scope of their analysis, and how they took that analysis and built self-service applications, tools using Tableau without having to write more custom operationalization or deployment code to really share those insights with a much broader audience, many of whom would be not data scientists, not advanced analysts. So that brings us to one question, though. Who is this session for? Well, of course, we're talking about data science and advanced analysis, so this hopefully will be interesting to the data scientists and analysts among us. But I also really want to share some of the ideas and the thoughts that we're going to explore with the business users, the people who are exploring the results of the work of a data science team. So for the data scientist, for the analyst, we're going to think about where does Tableau fit into a data science or an advanced analytics workflow, and how can we most effectively share the findings, share the results of our analysis. For the business side, hopefully this will provide you with some ideas on how we can really strengthen and further cooperation between the business and the analytics side, because when those two sides are really firing in sync, that's when we take the really exciting and deep data work of a data science team and actually put that into action and help the business people who need that insight work in the front lines and really solve those problems. So, first off, we're going to look at just connecting to the external services. Again, like I said, that'll just be a minute or two. Then, our use case number one. How can we build and share exploratory data analysis using Tableau and Python to share the results of exploration of a complex data set with a business group who wants to be able to dive in and further explore? Then, we're going to look at building a self-service time series forecast dashboard. So how can we build something that's iterative, flexible, and explorable for business users based on some of the most advanced time series forecasting code that we have available? And finally, we're going to look at how we can build and then deploy a credit scoring model into a dashboard application that someone on their local machine, on a tablet, or even on a cell phone could use to make decisions in real time based on the output of a deep learning neural network model. So first off, how do the external services work in Tableau? How do we take data from Tableau, pass it to some external analytics engine, and then return the results? Well, it starts with a viz or a data set. And in Tableau, we can create an external service calculation. These are called the script functions in Tableau. It allows us to write R or Python or call out to a model in MATLAB, crunch the data, using the very powerful open source libraries or even some closed source technologies, and then return the result as a table calculation into Tableau, which we can then dynamically render into a visualization. Now, actually, I was just chatting with someone about this a minute ago. One of the advantages of this approach is that we can build dashboard tools that multiple people can be using at the same time when they're deployed on Tableau server, and allow different people to ask different questions using the tool at the same time and get the appropriate but different results. So first, how do we actually connect in the product for those of us who may not be familiar? This is the dialog that we're going to see in 2018.3. The team has made a few changes. I just wanted to have a chance to put in a quick plug. We support selection of the connection types, RServe, TabPy for Python, and MATLAB. We allow you to now specify the specific type of service you're connecting to, as well as enter your host and port where that server is running. And new in 18.3, and this is a direction that the team is really heading with our work, we're adding security features for those connections. So you'll first see encrypted connectivity for RServe and Tableau Desktop, and then for server, and then ultimately for TabPy, as well as user authentication. So starting in 18.3, you'll be able to provide a TLS SSL security certificate and use that to encrypt your data as it's moving between Tableau and an external service. This is part of our overall push to really expand the enterprise scalability of these services. And so when we want to connect, this is the flow that we go through. Simply go to Settings and Performance, choose Manage External Service Connections, select your service type, enter any of the appropriate connection information. You can test if you want. And then when you click OK, you're good to go. So, now that we are connected, we're ready to write some code, what can we do with it? Well, any data science problem really starts with a business challenge. What's a question that we're trying to answer where it makes sense to invest the time and effort to really use data science, to use code, machine learning, and statistics to solve a problem? This was a question that a customer of ours faced, and they had a survey of customers of theirs, and it was a very high-dimensional data set, although if you work in something like bioinformatics, maybe not quite that high-dimensional, but they had dozens or hundreds of responses on this survey that characterized each of their customers. And they wanted to analyze, to explore which customers were similar, which were different. And they wanted to allow individual managers who were non-technical, who weren't data scientists, to be able to explore those results. So how do we analyze data that is high dimensional, but produce a result that anyone who may not be extremely technical can explore, and do so interactively? Well, if you've ever tried to build a single visualization in Tableau, encoding more than 2, 3, 4, 5 different variables at the same time, it gets somewhat challenging, and it's actually an assignment that I have my students at University of Washington do when they're first learning about data encoding for visualization, is try to encode actually the data set that we're going to look at here in one viz, and it's quite difficult. So how can we use techniques from data science to make that easier? This is the data set that we're going to look at. In our sample here, it's a data set of automobiles. So we have different cars and a number of characteristics that describe those cars. Number of cylinders, the retail price, the engine size, horsepower, a number of different variables, length and width and so on. So how can we create one visualization that captures the key stories in this data set? If we take a look, it's not really that easy to access. I mean, maybe you could scan through this and then try and pick out some of the numbers, but it's not easy. So the answer is we can use techniques from data science, in this case, principal component analysis, to decompose this data set and collapse it into a two-dimensional set of data that we can easily plot and explore in Tableau. And because it is Tableau, we have the ability to use dynamic filtering, parameters, selections, highlighting to make that tool even more accessible and digestible for users. Now, if anyone's not familiar with principal component analysis, or PCA, how it works, essentially, we can imagine the data plotted in some high-dimensional space, in this data set, maybe 10 dimensions. And principal component analysis looks for a vector or a line that we can draw through that cloud of data that captures the most change or the most variance. Once we've found that, that's our first principal component. And then you can imagine we're essentially just rotating that data so that component becomes a new axis in our data set. And for the second principal component, we draw an orthogonal line through that first one to capture the direction or the vector that has the second most variance. So principal components, especially the first two components, pull out a large amount of the useful change or information or story that's contained in a data set. And then when we put those in the proper context with the ability to compare them to the original variables that will make sense, so those things like number of cylinders, engine size, or price, it gives us a tool to explore the data in two dimensions, because we're essentially projecting it from the high-dimensional space where it originally exists down into something that people are very good at looking at, a two-dimensional scatter plot. And this is what we'll be building. So the answer to our challenge will be visualizing the data using principal components. We're going to look at how to handle that data and aggregation as it's passed from Tableau. We're going to build an interactive dashboard on top of that, and then visualize the results and also add some further exploratory tools. So we're going to use parameters and filters to make our analysis even easier. So if I was an analyst or a data scientist going to write this code and build a visualization based on PCA and Python, how would I do it? This is a pretty scaled down example, but it does work and it'll produce the result that we're looking for. So our first step, we'll load our libraries and load in the data set. In this case, we're loading in that cars data set from a CSV. Then we actually have the meat of our work, the real data science effort here, where we're loading the data, transforming it so that it's on a standard range, and then we are outputting a matrix and then converting that to a data frame that contains our newly minted principal components. So now I've decomposed the data, I've collapsed it into principal components, and I want to be able to see them. It's not much use if we can't explore them. So I have to write some code to actually visualize the results. And I get this. It actually doesn't look bad. I'm a big fan of the Viridis color scheme that we're using here. But does it answer any questions? I mean, we certainly can see something interesting. There were some outliers. There's a clear gradient, especially across that first principal component in terms of our feature here, in this case, miles per gallon. But which cars correspond to which samples? If I wanted to ask a different question, how do the components relate to number of cylinders or engine size? I'd have to rewrite code. And especially if I wanted to make this interactive, build a tool around it, I would have to write a lot more code to make it usable for somebody who could go in and explore it and do anything more than really just look at a static visualization like this. So what I want to do is allow Tableau to do that heavy lifting for me. I want to focus on my core challenge, which is answering the question, and then use Tableau to provide the infrastructure to actually visualize the result. And I want to keep in mind those three sections that I mentioned earlier. We have our loading our libraries and data. In the middle there, under purple, we have our core data science operation, where we're scaling the data and then extracting principal components. And then finally, at the bottom in yellow, we have our delivery code. That's how we're actually taking those numbers and visualizing them, making them interpretable. Now, in Tableau, this is exactly what that would look like. We've written a Tableau calculated field that contains Python. It's using a parameter to actually allow us to cycle through dynamically and select different principal components. And for those of you up in the back, if you're having trouble seeing this, these will all be made available after the presentation if you want to dive in and take a look. And we'll also dig a little bit into this code, because there are a few, for those of you with sharp eyes, key changes in how we've restructured this code to make it work in Tableau. And this is a big challenge that I've seen people run into, and it's one that I really want to spend some time addressing. How do we take that script that we just looked at directly from Python and adapt it to Tableau? There are really only two key changes we have to make. How do we make those changes? So here's a copy of that script, mostly the same as it was in Python. And there are only two changes we have to make. The first, that red section we looked at in the beginning, importing the data. Now, because we want to use Tableau dynamically, we're not going to read from a CSV. We're actually going to read data from Tableau as it's passed into Python or R. So we're going to get rid of that section up there, the read CSV, and we're going to replace it with Tableau's built-in functionality for importing data. In this case, at the bottom of the calculated field, we select the variables that we want to pass, and they're automatically encoded as variables we can call in our script. So we see up there, miles per gallon is underscore arg1, and that corresponds to the miles per gallon field that we passed in our calculation. Now next we see cylinders is underscore arg2, and that's because sum of cylinders is next in our list. So we see arg1, arg2, arg3, and so on. This convention is exactly the same for R, except instead of an underscore, we would use a dot arg1 or arg2. And so that's how we bring in our data. And then we're constructing it into a data frame to make it a little bit easier to work with. We're taking each of those variables, building a dictionary in this case, and then using the pandas library to build the data frame. Once we've done that, the meat of our code, the real crunching operations, the things that aren't really infrastructure, is exactly the same. We're doing the exact same scaling of the data, extracting those components, and producing the results as a matrix. So the only other change that we have to make is how do we then pass that data back into Tableau? Because we're building a calculated field, Tableau expects a column of result data that we're going to be able to pass back. So instead of that visualization code we have there, all we have is this section. We're just using Python to return a list of our principal component, or the samples encoded in principal component space. And in this case, we're using underscore arg8, which is that parameter that we talked about a second ago, to select which column or which component of that newly decomposed data we want to return. So the only two differences we really had to make were how do we import the data from Tableau, and how do we pass it back to Tableau? Our script worked in exactly the same way once we built a data frame and once we were returning the data as a list. So we have exactly the same 3 core steps: data import, data manipulation, which remains the same, and data export. And once we have exported that data, then we can use everything that's good and great about Tableau to explore it visually. Now, if I wanted to do this in R, actually, this is one of the cases where, so I'm more of a Python guy myself, but this is one of the cases where R actually, I have to say, is pretty great. This is the exact same data, exact same operation done in R. And this is one of the things where R is really nice because we have a lot of pre-built functions that give us some of this capability very natively. So all that principal component code that you saw earlier is captured in this one function in R, printcomp. And with that, I still have my same 3 steps. Data import, we're building a data frame out of values that we've passed from Tableau. And my data operation and crunching code, and as well as the results that we're returning, because this returns us a matrix of data that we can extract those components from. So in this case, actually, R is pretty straightforward and simple. So that was a lot of talk. We're here for visualization and exploration. What does this actually look like inside of Tableau? Let's dig in. So here we have our multidimensional automobile comparison. We have taken this high-dimensional data set and we have collapsed it into 2 principal components, which we plotted as our x and our y axis. These should contain a large portion of the useful information in this data set. But we're not really using Tableau to its fullest quite yet. We've been able to plot the data, and an analyst or data scientist might be able to look at this and start getting some conclusions from it. But principal components don't really mean much on their own. What do they mean in context of the original data? Now here's where it gets exciting, and here's where we can actually use Tableau to do that exploration. Right now, I see my vehicles are labeled. Might be able to get something interesting from that. But I want to ask a question. How does the data really relate to, say, miles per gallon? What's a key story we have in this data set? So I can use a parameter to select that variable and immediately color the data based on that. So here we have darker blue is higher miles per gallon, and yellow and orange is lower miles per gallon. So we get a sense that we're starting to see a bit of a story in this data set. On the right side, we're grouping vehicles that have higher miles per gallon, and as we move across to the left, we see the vehicles over there have a lower miles per gallon. But let's ask another question. Let's look at something like retail price. So now we see there's actually a slightly different pattern. We have some outliers down here, and these are very high-priced vehicles. And we can give some context to that because we can see exactly what these are. So we have a Porsche 911 down here, pretty expensive car. We have Mercedes-Benz SL55, CL600, fancy sports cars are starting to stand apart from the group down in this area. Over here, though, in our original section, where we had those high MPG cars, these are on our lower end. These are cheaper vehicles. So the cars in that area that we'll see show up are a little bit less expensive. Let's look at something else like horsepower. So we see actually the same thing. Those fancy sports cars down in the bottom left corner, those are high horsepower vehicles. So we're starting to understand what is the story that's contained in this data set. Down in the bottom, in this corner, we're getting towards our more expensive, fancier, higher performance, less efficient cars. Over here, we have our cheaper, but much more fuel efficient vehicles. And I can ask one more question. What does weight look like? And now we see even a slightly different pattern. The darkest vehicles are up in this upper left corner. Those are, if we look at them, Hummer H2, pretty big car, Lincoln Navigator, Chevy Suburban. These are our big, heavy vehicles. So we can start to see that the key story captured in this data set. Cheaper, more efficient, lighter cars on the right, bigger, heavier, more expensive vehicles on the left. If we want to actually confirm that, I can use Tableau's interactivity to select a subset, say our hypothesis about these cheaper, lighter cars over here, and I can use highlighting to see where they fall on a range of our different variables. So I've selected what I thought were our lighter, cheaper cars. I can see they're on the higher end of city miles per gallon. They're on the lower end of number of cylinders. Cheaper, lower end dealer cost, small engine size, low horsepower, but very high highway miles per gallon. They're typically shorter and on the lower end of our weight scale. Now, if we selected our sports cars down here, we can see the opposite. Not really doing good on miles per gallon efficiency, but high number of cylinders, very expensive, typically larger engine size, very high horsepower. So I've already started to build a tool that someone can use to explore. And as new data were to come in, I can say I want to look for specific customers. So say I want to look for all our Acuras. I can see they fall actually pretty squarely in the middle. So they're not really differentiated by any of those key variables that we looked at. They're kind of in the middle of everything. If I looked at something like our Mercedes, we see they actually have quite a few different offerings, but they tend to be a little bit more down and to the left. Those are our high performance, more expensive, smaller vehicles. So I've built a tool that I can use to start asking questions and explore the results and really share the stories in a complex data set. If I wanted to filter it down even more, I could say I only want to look at our Fords. And I can see where the vehicles within our Ford manufacturers fall in and how they compare to each other. So I've taken this model, this transformation, and turned it into an interactive exploratory dashboard that with a little bit of training, I can share with less technical users and allow them to hunt for the key stories in the subsets of their data. And you can imagine if I had different managers who each owned, say, hundreds or even thousands of different customers, they could filter this dashboard to just their appropriate customers and use that as a tool to find outliers, find groups, and really dive in and start to explore. So that was our first use case. One tip about using the external services: these calculations are based on table calculations in Tableau. So setting the correct detail is very important. In this case, we have a data set where the atomic detail is a car. So we want to make sure that when we're passing data, it's at the appropriate row level. So when we construct a data frame inside of Python, the data is appropriately matched. So here, we want to make sure that we're passing all of the data as one single table. So we have, this is our underlying data set. This is our atomic detail. And when we compute that table calculation, we want to make sure to actually check the box under specific dimensions next to vehicle. That means that we'll make one single call to Python and pass everything as one big block. If I were to say uncheck that, that's called partitioning on that member or that dimension, and I would make a call for every distinct value. In most cases, that's not very performant, because even if a call resolves in 10 milliseconds, they add up very quickly. And in this case, the code wouldn't even work because I need all the data passed at once to generate those principal components. And that allows me to build my two-dimensional scatter plot. So let's move on to another use case. This is actually one that we worked on quite recently with a partner of our customer of ours down in San Francisco, NetApp. We actually, I believe, have some people here from NetApp today. So this was actually a great use case because they were interested in adapting a script to build an interactive forecast explorer for their business managers. This would allow them to forecast the performance of their products and do so dynamically with the latest data. And they had a large cross-product of managers and products and customers, so it didn't really make sense to pre-compute this forecast. We wanted to generate it live on the latest data. And this is where it actually really makes sense to use the external services for that dynamic, interactive forecast capability. So that was our question. How can we allow users to visually explore a forecast, share product utilization information with the business, and on data that's current? So the answer was to adapt an existing script for Tableau and present that result as a dashboard that anyone could log in and interact with, and it could be deployed on Tableau server to allow users to do so dynamically. So, how did we go about doing that? And the biggest challenge here was how did we actually adapt that script? In this case, it was an R script. I'm going to show an example with Python, although these materials will be available after, and we have examples for everything I've shown in R as well as Python. So we had to understand how we appropriately wanted to pass the data and how to return the correct forecasting results. And then the actual deployment, how do we build something that a business user could use as a tool, make it interactive, dynamic, and share it out in a way that anyone could go in and access who needed to? So we got to this forecasting application. So again, we started out with a script. And the script followed basically these three parts. This is how we would do it in Python. And in this case, I'm using the Profit library from Facebook, which is a really great out-of-the-box forecasting library. And if I were to write all this code, import data, build a forecast, I would get this result if I plotted the data. Interesting. See, the forecast looks like it's pretty good, but we see some outliers there. I don't know what data points those are, if there's some pattern within them, if I wanted to dive in further. We can look into the future. It looks interesting, but just with this visualization, it would be hard to really go much further. So I'd have to write a lot more code to make this useful and operational. And to take those three different components of the code and actually make that useful. The loading the data, the actual operations, and the return results. But in Tableau, those first, the first and the last steps, the loading of the data and the actual deployment and operationalization and visualization, interactivity, is all given to us. So I can take most of the meat of that code and adapt it very easily. So how do we do that? Again, we're going to walk through the process, but I think you'll start to see a pattern here with how we adapt the code, because there's only, again, really two portions that we have to change. First, the data import, and then the data export. So this is our script that we actually use in Python to get the results that we're going to see. I'm using a parameter in this case to interactively determine how far into the future we actually want to forecast. So I can change the length of our forecast interactively. So that's our first step here. We're loading in using a parameter, the range we want to look into the future. Then again, we see the same steps for loading data. We're taking two variables, a date and our target variable that we want to build the time series forecast on. We're passing those into a data frame. In this case, there's a little bit more we have to do because Profit expects a certain structure of data frame with a column called DS and a column called Y. That's our date and our target. And then the meat of the code remains exactly the same. We're not making any changes there. And we have again, those three steps that we're taking. The loading data, that data crunching code, and then the return result, how we're shaping and structuring the data to pass back to Tableau. So once we worked on adapting the script, and this was where most of our efforts were focused in this case, working with NetApp, it was actually quite quick to build a dashboard that was interactive, explorable, and visual using the results of that forecast. If we wanted to do this in R, again using the same profit library. Not quite what we did with NetApp, but this example follows the same course. We have exactly the same script. This is written in R, but you'll see follows the same 3 steps: loading data, manipulating that data, and passing it back to Tableau. And using those, we can actually build that forecast into an interactive, shareable dashboard. So let's take a look at that. So see, the model will compute dynamically. And if we had new data, this would be taken into account as we run the forecast. And now we've built this time series forecast application that anyone can go in and filter and use to look at their specific subset of data. So we're able to visualize not only our historical data and the forecast, but also how the model was fit historically to that data and other interesting and interactive visual components of this data set. So here we're looking at number of logins on a given website for, say, different customers we might have. We can select those customers, and when we do, we can see how they're performing, and we can get an interactive forecast that looks out to the future. So here I've selected one of our customers, Quack LLC. We can see things look like they're trending a little bit down in terms of overall logins. Our forecast looks like it's maybe leveling out, but it still has descended quite a bit. If we look up above, we can see the log scale. So we can see that the trend has been, again, headed down. We've seen negative year-over-year growth over the years that we've been tracking this website. And if we look at our monthly breakdown, they don't account for much in terms of a visual slice of how many hits we're seeing in our overall program. But let's select a different customer. I'll pick Nagara Consortium. And again, we'll rerun our model here. And now we can see Nagara Consortium is actually doing really well. This forecast is trending up, got a lot of hits, it's growing. See the log scale is tilting up, that shows us growth. We've seen pretty solid year-over-year growth, although not our strongest in terms of percent growth. And we can see that Nagara Consortium accounts for a decent chunk of our hits, maybe half or more across each month. So we can go even further, and this would scale up if we had dozens or hundreds of customers. If I wanted to know exactly what a forecast value was on a given day, I can explore that as well. And say I wanted to change the range of our forecast. So we're looking 500 days into the future. What if I wanted to, say, go a little bit further and look 1,000? I can do that as well. And again, the forecast will rebuild dynamically. So if we had more data coming in, this would be accounted in. Now, for those of you familiar with forecasting, looking this far out, we're probably getting into sort of a very uncertain territory here. But we can do that. Or we can cut things short. Maybe I want to be very tight and only look 50 days forward. We have that ability as well. So, how did we actually make this possible? Now, one of the sort of general operating principles of Tableau's external services is we return one value for each value passed. There's a one-to-one relationship for each row passed to a result return. And that's true in most cases, but there's a way that we can actually get around that for time series forecasting, because obviously it doesn't make sense to return exactly as many points as we pass for a forecast, because we want more data that we've generated. We've built a forecast that looks into the future. So this is a trick that we can use to actually expand our forecast forward in time. We can use a level of detail expression in Tableau to find the highest, most recent day in our data set and fix that with an LOD. Then we can date add, in this case days, some number of values into the future. So we found our greatest date, and taking that date, we're pushing it some number of days based on our parameter forward into the future. So this will create a gap, the size of the parameter, between the second most recent date and the first most recent date. So in the example here, it's 500 days. And this creates a visualization that looks like this. We've got 1 point pushed into the future, and the second most recent point is some number of days behind that. It doesn't look great, but it's a stepping stone to what we need to do, because we can use another great feature in Tableau. If we click on that new date field we've created, we can check Show Missing Values right here. What this does is actually date pad between that second most recent date and our first most recent date, and now we've actually created a number of empty values, so we're able to pass more data to the external services than we had in our raw data set. And this is the mechanic that we can use to push Tableau a little bit further and allow us to return more data. I'm also using a table calculation filter here to hide that final step, that point that's way out into the future. So this is just setting last equal to 0 and then setting that to false. That'll show every mark except for the very last. Now, once we've got that messiness out of the way, we're able to construct these time series forecasts that actually return more data, return that dynamic future forecast, and allow us to explore that and present it inside of Tableau. So, finally, we've looked at two examples where we are actually writing ad hoc code inside of Tableau. We're writing Python, and when you look at these after, you'll see R as well, dynamically in a script function. But that can be challenging for a number of reasons. One, we may not want to give that code out to everyone. We may not want to allow people who are capable of, say, web editing on server to go in and make tweaks or changes, even if it's good intention. So this is a capability that's native to our Python integration, TabPy. We can actually take a function, deploy it to our TabPy server, and then call that function with one line of code by name. This gives us the ability to store pre-built code or pre-built models and functions that we want to use. It also gives us an ability to version them. When they're deployed in Tableau or in TabPy, they are versioned, and so we can track if any changes have been made. Now, using this type of deployed model, we can train a model and use that code for future predictions. So this is a problem we see with quite a few organizations. How do we take this model, deploy it, so that a wider range of people can actually use it? And we've seen even scenarios where the relationship of people building models to people consuming them is 50 to 1, 100 to 1. So there's a lot of value to be had in creating a scalable and easy to maintain a simple path to deploying those models. So we have models we want to push into production. We have business users that want to learn and consume them. So our answer, deploy that model in TabPy, and then make it accessible through an interactive dashboard. We can take code, in this case we'll show a Jupyter notebook, train a model, deploy it in TabPy, and explore the results in an interactive dashboard. So the steps here, building and training our model, adapting that model for Tableau. Model simulation. Once we have that model deployed, we can actually use the interactivity and parameters in Tableau to pass new data and generate new results from the model that we may want to explore in real time. And then we can use Tableau Server to share and scale this application. And that gets us to our scorecard, what we're going to take a look at today. So again, let's dive in. So here we have our credit classification, our loan scorecard simulator. What we're able to do, we're calling out to a pre-trained deep learning model, a 3-layer neural network that's been trained on data on loans and whether those loans ended in default or were fully paid off. And we're using variables that we can pass to design a new loan and assess the model's prediction of the probability that that loan will end in default. So you could imagine someone taking this on their laptop, on their tablet, even on their phone, calling out to this model and getting a result immediately that they can then use. We have visualizations that we can also use to explore and put those results in context. So let's say we have an applicant come in, their pre-screen grade is a C. Their subgrade, we'll say, is a 0.4. And we know this is a little bit risky. The purpose of their loan, they're looking to start a small business. We're calling out to the model. Immediately we can see where that customer falls in context of our other previous loans, as well as a prediction for the model. We see that when we said they were looking for a home or a small business loan, immediately the risk jumped up quite a bit, and we can see our corresponding metrics that are built off of that. So I'm actually feeding new data, generating a new customer, and seeing how the model predicts the results. So let's try something different. Let's say they're looking for a credit consolidation, debt consolidation loan. Already that's going to make them much less risky. They have a very high income. And say their debt to income ratio is a 2, pretty low. There's a 1. And they're a grade A applicant. So we can see the model is telling us that this person has a very low risk of default. Now, this was actually trained on a data set of very risky loans. So in this case, we're learning that the interest rate for this loan is actually quite a bit lower than we would have for some of our riskier loans, but that the overall risk is significantly lower. So we have this model that we're calling to through a dashboard. How are we doing it? I mentioned earlier that we didn't have to write any custom code, and that's because when we actually look at this model, all we're doing is calling out to a deployed function. So we've pre-trained this network, we've deployed it using TabPy, and then we can call it and pass variables to the model in real time. So, take a look at how do we do that. Like I said, this model was trained in Jupyter, so we'll take a look at that in a second. While that's loading up, we looked at the code here. Using Tableau parameters, we're able to simulate different types of data. So we're passing strings or integers or real numbers, and our code is able to handle those, transform them into the input the model expects, and then we're able to generate that response, that score, in real time. So before we jump to the conclusion, we'll just take a very quick look at that Jupyter notebook. This is our loan classifier. So, we see again, on a bigger scale, we're following the same flow that we saw before. We're loading in our libraries, loading in our data set, doing some quick, light exploratory analysis, just verifying the integrity of our data. Then we're splitting the data into a training and a test set, scaling it, and constructing a neural network, in this case using one of the pretty basic scikit-learn multi-layer perceptron networks. We're fitting that model, doing some evaluation of how it's performing, and then finally, these are the key steps for Tableau. We're defining a function that expects a certain set of inputs. We're using our pre-trained scalar and pre-trained model to take that input and produce a prediction of the probability of a loan ending in default. Now, this is the great feature about TabPy. When we deploy this function, like we're going to do in a second, it will actually automatically pickle the code that we've trained before. So the state of the model and any of the scalars or pre-helper functions that we've used will be persisted when we deploy it. So we don't have to ever retrain the model again unless we want to. And deploying it into TabPy just takes the client library for our Python integration, TabPy. We have to just connect to that server and then run the deploy method. We give the function a name, a brief description. We can allow override equals true if it previously exists and we want to overwrite it. And once we've run that, we have our fully deployed model that we can call to from Tableau without having to write more than one line of code. So, we've now covered a range of 3 different use cases, 3 customer scenarios that we've seen, showing decomposition, allowing people to explore high-dimensional data. With NetApp, looking at building a dynamic time series forecast application, and with many other customers, operationalizing a model behind a dashboard and deploying that function with Python. So from a data science perspective, framing business questions, then building a model, and finally using Tableau as our infrastructure, as our vehicle to deploy that model without having to write or maintain any custom code. And from the business side, exploring complex problems in a more simple visual medium, and scaling the collaboration between data science and the business using Tableau and Tableau Server. And so this ultimately falls back, how does Tableau fit into a data science workflow? Here, we've mostly focused on deploying a model, operationalizing a project and an idea. We also definitely see people using Tableau in the exploratory context, but I really see most of the power from Tableau in data science and in more advanced machine learning as a way to share, make interactive, and scalable the results of a data science project. So thank you very much. I really appreciate your time today. Definitely can open it up for questions for the next few minutes for anyone who's interested. So I'll call on you and then I'll just repeat the question out loud. So yeah.
So confidence forecasting provides confidence bands.
Mm-hmm.
Is there a way to return multiple columns?
Yeah, so the question was for Facebook's profit, we can return a confidence interval. And actually I have in the example, so if you look at the workbook, we can call those with other functions and return it as well. So we can only return one column per function, but we can build multiple functions and put those in the same visualization to show that confidence interval. That's right. So that exact thing on handling data frames is something that, as the PM, I'm interested in for the sort of longer-term future of the feature. Great question. Yeah. Yeah.
Will the data files be available for us to practice exercise?
Yeah, absolutely. So all of these examples, the PowerPoint and the workbook itself, will be made available after the conference. Great question. Yeah. Yeah. You're asking about the number of samples?
In the first dashboard, the CA filtered and narrowed down to our observations. And then my question is, are we just like showing those 4 observations on their scores, or are we just recalculating the CA because
Yeah.
it's really
Great question, and yes, you're absolutely right. So in this example, we are actually doing a filter of the data, so we are recomputing the PCA. We could use a different type of filter in Tableau to only visually hide the other results, so we're still computing the same set of principal components, but just only showing a certain subset. So we could do both if we wanted to. Yeah. Yeah, great question. So the question was, is the external services, are they R in Python available in Tableau Online? The answer is not currently, although that's certainly something that we're thinking about for the future. I'm going to jump down to, jump down to this side. But I'm fine to stick around after, so if you have questions, please come down and talk to me. Yeah.
So to point or to TabPy, could you alternatively just, in advance split up your script from a function and then import the function past the parameters? So in Python, for instance, run everything in 2 lines of code instead of doing any of the custom coding in Python?
Yeah, you could call other functions as well. And for R as well, if you save or persist an R file, you can call that in your R code if you have a pre-trained model. We had a question right there. So this is a real-time result. So it's building it in real time as the visualization is built.
How big is the data set?
In this case, the data set I think was 5 years, and each day within those 5 years. So 1,500 rows, but it goes up. So I would say last night I used TabPy and Tableau to do sentiment analysis on all of the comments from the first day of sessions. That was, I think, 5,000 or 6,000 comments, and that resolved in like a second or two, and then I was able to save that and keep working with build a dashboard that we sent out. Yeah.
Can Tableau return the data frame from R, or it just need to be a vector?
Yeah, so right now, the way that the services are architected, it's just a vector from R or a list from Python. The ability to actually return a full data frame is something that the team is certainly interested in looking at to expand in the future. One workaround... it's not on our roadmap right now, but it's something that we have definitely heard a lot of requests for. So it's something that we are interested in looking at going forward. Yeah.
So right now, just a vector. Okay.
Just a vector, yeah. One workaround that we've seen people do with that is actually using the functions, either R or Python, to write out to a database, persist those results, and then be live connected to a table in that database. We've seen people actually do some really cool stuff with visualizing the structure of, say, a decision tree where the user can tweak parameters or include or exclude certain data and see the structure of the tree change as they do that for sort of dynamic, again, an example of exploratory analysis. Yeah. That will depend on the use case. If you're crunching row by row on terabytes of data, you might run into performance issues. I mean, I think that you would. So that's where you could use Python, though, to call out to another service that is like a distributed computing environment or graphical computing that is running that way. So you could call out to that if you had the system and the hardware under it. Yeah. You had one in the back, and then I'll. Yeah, that's a great question. That's something I have run into a little bit trying to pickle a Keras model from Keras on top of TensorFlow. I have run into some issues with, so the native library that TabPy uses to persist is pickle in Python. I've run into sometimes issues with that. So it should handle most normal Python objects just fine, but when you get a little bit further like that, there may be some issues with it. And then, yeah.
So when you run your models, does Tableau have the information like precision and recall and available in the visualization, or is it like an info button on this?
Because we're calling it to Python, that's not available in Tableau automatically, but you could pass that back as well. All right, any others? Way up there. Yeah, so the question was, we were using Tableau parameters in that last visualization. Does that require any aggregation? In this case, no, because we're essentially passing only one row of data, so it's just taking the default value of that parameter. Yeah. It is really dependent on the kind of code that you write. There are certain things in R that may be less performant, but it will depend on the situation, I think.
Tableau supports R natively, right? I mean supports R from Tableau and Python is community support.
Well, so those refer to the actual servers that we use to connect to it, but they essentially follow the same mechanism. There's rserve is the package in R that we run as the R server that we use to communicate with R. TabPy is the Python one, so the steps are essentially the same for each, just the rserve is a supported connection from Tableau. TabPy is currently a community project, although that's actually something that we are, as a team, working towards in the next few quarters. We'll be beefing up our support for TabPy as well.
And if we're doing something with Julia for speed, how would that work?
Yeah, that's a great question. That was actually something, so the team, some of which are actually here in the audience right now, in our previous session, we were talking about some of the ideas we've had for the future. One of those would be an expanded set of integrations for things like Stan or Julia or any of the other languages that people are using for analysis. Currently, there's no direct way of doing that, but I believe there are ways you can use in Python to call out to Julia, so that would be the best way to do that right now. Do we have anyone? All right, down there.
Earlier when we were talking about filtering on the decision tree. So for my specific use case, I have hierarchical clustering. I'd like my user through the visualization to be able to say that things were misclassified or misclustered, I guess. But then that ultimately would rerun the model on that subset and rematerialize and refresh my tables in Tableau. Is there a way to do that in the workflow?
Let's chat a little bit after this because I can get into that in a little bit more detail. All right, anyone else? Okay, well, come down and talk to me. All right, well, thank you very much. My email is nmannheimer@tableau.com, nmannheimer. Please reach out to me if you've got feedback, and of course also, please fill out the survey as well. And thank you very much.